Hello, so this is a video for the following problem. Of course, your numbers are going to be different, but the concept should be similar. So the problem says, let the universal set S have 73 elements. So I'm actually going to also, as I'm reading the problem, I'm going to represent it using a Venn diagram. All right, so we have universal set, and in this problem, it's labeled S. And so the cardinality of S is 73 elements. So that's the total number of elements in the universal set. Now, this set has two subsets, A and B. This is A, this is B. Okay. And it says that set A has 43 elements. The cardinality of A is 43. And set B contains 44 elements. So cardinality of B is 44. Now, we know that when we talk about cardinality of A, for instance, that means the 43 elements total. So there's some elements that are just in A, and then there's some elements that are in A as well as B. And so the total of those two types of elements would be 43. And so same thing for B. We have some elements that are just in B, and some elements that are also in A, and the total of those would be 44. And so we're also given that that A and B have 36 elements in common. So that means we can place that number in the middle. So there's 36 elements in common. Okay, so knowing how many elements are in common allows us to fill in the rest of the Venn diagram. Because since we know that set A, for instance, has a total of 43 elements, if I take away the number of elements that are also in B, that's going to leave me with 7 elements. So there's 7 elements that are just in A. So always check your totals after you're done. So 7 plus 36 should give you 43 back, which is the total number of elements in A. And then same thing we can do for B. Same idea. To know how many elements go here in the just B region, we have to take out the 36 that are also in A. And so that leaves you with 8. Okay. Now, at this point, let's go ahead and read what it is that we're asked to actually find. So how many elements are in B but not A? So right now we have that number. So there's 8 elements, right? There's 8 elements that are in B but not A. That should be it. Now sometimes the question might ask you to figure out how many elements are neither in A or B. So that would be the number of elements that are outside of the two circles. Now to find that number, what you would have to do is just go back to the total number in the universal set, so 73, and subtract out the number of elements, distinct elements in A or B, which would be 7 plus 36 plus 8. Or also you can find that by adding the 43 and 44, subtracting out 36. So 51. We subtract out 51 from 73. That gives me 22 elements. However, we don't need that number because all we're asked to find is how many elements are in B but not A. So that would